We now correct the second question, that's this one right here. And to begin with, I'll just copy out the sequence again. We need to find the formula for the sequence whose first terms are 13, 10, 7, 4, 1, and so on. Now, the first thing we need to do is look at the differences between the terms of this sequence as we go from left to right. So from 13 to 10, we're taking away 3, so we say we're adding negative 3. From 10 to 7, we're adding negative 3 again. From 7 to 4, we're taking away 3, or adding negative 3. And from 4 to 1, again, we're taking away 3, which we should think of as adding negative 3. Now, since we're always adding negative 3, we're always adding the same amount. And that means that this sequence is linear. And because it's a linear sequence, it must have a formula that looks like un equals to a times n plus b. So our job here is to find the values of the coefficients a and b. And to find a and b, we have two equations. Those are a equals to the difference, and a plus b equals to the first term. Now remember, those two equations will be true for any linear sequence. So for this particular sequence, we'll have a equals to the difference, which is, well, it's negative 3. So that's a equals to negative 3. And a plus b equals to the first term. So here, that's 13. So we have a plus b equals to 13. And those are the two equations we'll use. We now set off to solve them. Well, a equals to negative 3. There's nothing for us to do there. That's that. We move on to the second equation, a plus b equals to 13. But since we know that a is negative 3, this turns into negative 3 plus b equals to 13. We now add 3 to both sides of this equation, which leads to b equals to 13 plus 3, and finally b is equal to 16. Now that we have both of the values of a and b, we can go ahead and state this sequence's formula. That would be un equals to negative 3 times n plus 16. And there we have it. That's the formula for the nth term of this sequence.